Bitcoin Core ships with over 100 configuration options. Most people use the defaults and either run out of disk space in 6 months or waste a perfectly good server running a node that could do 10 times more. Here's the thing, just 6 settings separate a bare-bones Raspberry Pi node from a full API backend powering a Bitcoin business. Let's break down exactly which knobs to turn and why they matter. To understand which settings matter, first consider what a node does. When you run Bitcoin Core, your machine independently validates every transaction and every block against the consensus rules encoded in the software. You don't trust a bank. You don't trust a third-party server. You verify everything yourself. You also strengthen the network. Every additional independent node increases decentralization and makes Bitcoin harder to censor or attack. That's the motivation. Now let's look at the cost. Running a node costs real resources. The full Bitcoin blockchain exceeds 500 gigabytes. That's your initial download. It grows by roughly 400 megabytes every day. Your node also uploads data, relaying blocks and transactions to other peers on the network. This consumes bandwidth continuously. Memory holds 2 critical data structures. The UTXO cache stores unspent transaction outputs, the set of all spendable Bitcoin balances on the network. The mempool holds unconfirmed transactions waiting to be included in a block. And your CPU validates every transaction's cryptographic signatures. If you're on a metered internet connection, Blockstream Satellite offers an alternative, receiving blockchain data via satellite dish, bypassing bandwidth limits entirely. These costs are why configuration matters. Bitcoin Core reads a plaintext configuration file from its data directory on every startup. 1 setting per line, formatted as name equals value. You edit this file, restart the background daemon, called Bitcoin, and your node adopts the new behavior immediately. To check on your node, you use a command line tool called Bitcoin curly, which queries Bitcoin for status information like block hide and the peer connections. Every setting we'll cover goes into this configuration file. Here are the key configuration settings. Think of them as tuning knobs on a mixing board. Datadir sets where your blockchain data lives on disk. Txindex, the transaction index, when enabled, lets you look up any transaction by its ID, not just your own wallet's transactions. Prune deletes all block data after validation to save disk space. dbcache controls the in-memory UTXO cache size. The default is 450 megabytes, roughly 450 megabytes. Raising it reduces disk reads. Lowering it conserves the RAM. Blocksonly disables relaying unconfirmed transactions, cutting bandwidth substantially. Maxmempool caps the memory your node dedicates to pending unconfirmed transactions. And alertnotify triggers a custom script when Bitcoin Core detects critical events. Right? Each knob trades off between resource consumption and functionality. Now that you know the knobs, let's turn them to opposite extremes. Profile A, a full API backend powering wallets, block explorers, or payment processors. Set txindex to 1. This indexes every transaction ever confirmed on the blockchain. Without it, you can only look up your own wallet's transactions. With xindex, you query any transaction by ID, essential for applications serving external users. Point datadir at a large fast SSD. The blockchain exceeds 500 gigabytes. Slow storage bottlenecks lookups. Set dbcache to 2048 megabytes or higher, up from the 450 default. This keeps more of the UTXO set in RAM, dramatically reducing disk I/O during both initial sync and ongoing operation. Enable alertnotify to run a custom script on critical events. Email alerts on long forks. Webhook triggers for your monitoring stack. Leave prune disabled. You need the full blockchain on disk for txindex to function. Profile B is the opposite, a resource-constrained node on a Raspberry Pi or cheap VPS. The goal is personal sovereignty, validating your own transactions without overwhelming limited hardware. Set blocks only to 1. Your node stops relaying unconfirmed transactions to and from peers, saving substantial bandwidth. You still receive and validate every confirmed block. Set prune to 550, the minimum value. A critical point, pruning does not weaken validation. Your node still downloads and verifies every single block from Genesis. It deletes old block data after verification to reclaim disk space. Instead of 500 plus gigabytes, your disk footprint stays around 550 megabytes. Set dbcache to 150 megabytes to conserve RAM. Cap maxmempool at 50 megabytes. One hard constraint, txindex and prune are mutually exclusive. You cannot build a full transaction index from blocks you've already deleted. For bandwidth-capped connections, Blockstream Satellite can deliver blockchain data via satellite dish instead of internet. Step back and see the pattern. Every setting trades resources for functionality. Prune saves massive disk space but loses historical block serving. Txindex costs disk space but unlocks full transaction lookups. dbcache trades RAM for reduced disk I/O. Blocksonly cuts bandwidth but drops visibility into unconfirmed transactions. Maxmempool caps memory at the cost of evicting low-fee pending transactions sooner. No free lunch. You choose where your node sits on each axis. You've chosen your profile and edited your config file. Start Bitcoin in the foreground first to watch the logs. The initial blockchain sync takes hours to days depending on your hardware, internet speed, and the dbcache setting. A higher dbcache dramatically accelerates this process. Monitor progress with Bitcoin CLI. Check the current block height and compare it to the network tip. Don't set and forget until you've confirmed blocks are downloading and validating correctly. Once synced, test your setup. Run transaction lookups if you enable txindex. Check disk usage if you enabled pruning. Right? Configuration isn't a one-time choice. Your node processes about 400 megabytes of new data every day, and the settings govern that continuous workload. Once your node is synced and tested, add Bitcoin Core to your system's startup scripts so it runs automatically on boot. A node that's powered off validates nothing. Step back and consider the bigger picture. The fact that a $50 Raspberry Pi can fully validate the entire Bitcoin blockchain using pruning, blocksonly mode, and conservative memory settings is by design. Bitcoin's configurability ensures that financial sovereignty isn't reserved for data center operators. Whether you run a full API backend on a powerful server or a minimal node on a single board computer, your node enforces the same consensus rules with the same rigor. Your configuration choices shape not just your node's performance, but the decentralization and resilience of the Bitcoin network itself.